Hey, I'm Alan Furstenberg.
And I'm Mark Tucker. Welcome to Two Voice Devs.
Two Voice Devs. Hey, Mark, how's it going?
It's going well. I'm just excited to kind of see where things are going with you presented a possibility of a topic today, and I'm like, yeah, I'd like to learn more. So let's get into it, I guess.
Sure. Well, so it was kind of interesting. This topic kind of came about in two ways. One was while I
Right.
was editing the video that appeared last week on Vodo Drive. We talked a little bit about LangGraph in it, and you made a comment about how it'll be interesting to hear more about LangGraph. And while I was editing it, they announced a new release version of LangGraph and some supporting tools for it. So,
Okay.
although I haven't dug into the supporting tools yet, I thought it might be a good thing. Might be a good transition and segue into from last week to this week to kind of talk about it while it's a little fresh in our minds.
Okay. Yeah. No, that sounds good. I'm anxious to get into it and learn a little bit more.
So, from what you might remember from last week, LangGraph it's a state management system. It's essentially a way to build directed graphs, and these graphs change state from node to node to node. So probably one of the easiest ways to kind of get an idea on what we're talking about here is LangGraph has some sample code they have. Let's take a quick look at it and we can kind of get a first idea on what that looks like.
Okay.
So what we're looking at here is a definition of the state graph. And on the surface, it looks kind of complicated, but it's really pretty straightforward. The state graph will take a type of messages annotation, and that's what the state itself is. So basically, it's going to be handing around an object of a messages annotation as it goes through these nodes. And then we define two nodes. The first node is called call model, and there is a function here that is defined for that node. So nodes are functions or function executions.
Okay.
And then it's defining a node called tools, which is of a predefined type tool node. Since tool nodes are extremely common in LangGraph, they've predefined it. This is what is going to be executing all of the tools. So, if you remember from last week, tools are basically the functions that we teach language models exist. So these would be things like, in our prototypical examples would be things like get weather,
Right.
or in Vodo Drive, it was things like open sheet, add row. So this is what we're telling the LLM what can be done. These are the actions, the things that it can do.
This is what I know how to do.
Right.
And the parameters and kind of a definition of what the thing
Exactly.
is. Okay.
You're giving the LLM enough information to know more about it, make decisions about when it's going to want to call a tool and when it's just going to want to return a message. So
Okay.
we've defined two nodes. One node is where we call the model, and it's going to hopefully return either a message or tools, and one where it's going to be calling the tool to execute the tool and then returning the information which gets sent back to the model. So far, so good. We've got two nodes. We then need to add an edge or a transition between those nodes. And the first one is we're going to say we're going to add an edge from the start to the call model. So when it starts, it launches into call model immediately with the messages that it has so far. Pretty straightforward again.
Okay. Yeah.
Okay. We're also, and I'm going to skip this conditional one for a moment. We're also going to add a node so that once it's called the tool and once the tool information's been added to the state, go to the call model mode so it can call the model with that message, that information. So far we're picturing two things, and I'll probably put up an illustration of this as well. We're going to start and go to the call model, and after we run a tool, we're also going to go to call model and pass
Okay.
stuff back to the model. So far, so good. The other catch, though, is that once we've called the model, we may want to do one of two different things. And this is where the conditional edge comes in. The as kind of the name implies, this is an edge. It's a transition between two nodes, but it picks which node it will go to instead of just going to one node.
Okay.
So a conditional node is defined with two major parameters. The first is what node are we going to be starting in this case, call model, and then the name of a function, route model output. And route model output will make a determination about which node it should go to next. And then we have an optional third parameter which has a list of those nodes that it could go to. And that third parameter is mostly there for graphing tools. It's advisory only in this particular case. But what it's going to say is that route model output will either route us to the tools node, where we call a tool, or if no tool was selected by the LLM, we're going to go to the end. We're going to finish things off.
Okay.
So pretty straightforward. If we then go up and look at route model output, we can also see it's in some ways fairly straightforward. So it's going to take the message annotation state, take a look at the messages that are in that state. Like the main thing the state is storing are the messages between the LLM and something else, either the agent side of it or the human side of it.
Okay.
And we'll check to see if the last message includes the fact that it had a tool call. So if the LLM is saying, here's the tool that I want you to call, then we need to go to the tools node to call that tool. Otherwise, it's returned a human message and let's end.
Okay.
Make sense?
So mostly, I've got some questions, but
okay.
So I'm thinking from a user's perspective, they go to a chatbot that is backed by LangGraph, and they're typing some user input in, like, what is the weather in Phoenix?
Yep.
Right?
Okay.
So we're on the start node, and the first thing that it's going to do is go to call model. And so it's the LLM is going to get called for the first time asking what the weather is in Phoenix.
Correct.
What is it that determines whether it's going to just answer based on, I don't know, something the LLM knows or will make up? Or how does it know that it's going to look in its list of tools and see if it can, if it has some tool that can help it answer that?
So there are a couple of elements here about that.
Okay.
If we look at the call model function, the call model node, it's defining a model. And this
Okay.
is, in this case, it's using Chat OpenAI, but this could be any model that supports tools. And we are binding a set of tools to it. And this is a standard way that LangChain attaches tools to a model. So
Okay.
we're basically defining a model. We'll also be defining, system prompts and some other and history of messages and so forth. But we're binding a set of tools to it. So it's the LLM that determines, should I tell it to use one of these tools or should I give it an answer? And that's a function of the LLM itself. That part clear?
Okay. Yep.
Okay. And as we see, as part of what this node does, it returns the response. So it's basically saying we're going to return a single response, and we're going to let the state management system under the hood determine what the new state is based on this single response.
And what's the prompt?
It's a pretty
Okay.
standard system prompt.
Okay, so it's just letting the system, letting the LLM know what today's date is, but not, it doesn't have any knowledge as far as what types of answers that this assistant can answer. So we know, like from our example, that it's going to be a weather example, but it doesn't necessarily know that that's gathered from the input.
It knows what it can answer because those have been bound in the bind
Gotcha.
tools.
Okay.
So if we look at, in this example, it's doing search results. So the tools defined here are a tool that will do search results.
Okay.
But instead, I could have put tools here to get weather information or whatever it is we want the system to do.
Okay. All right.
Okay, but yeah, the system prompt is otherwise just providing other context that may be important. And in this case, there isn't too much more that it needs besides your helpful assistant, what the current date is. There's a lot that goes into finding good system prompts for tool calls.
Okay.
The one that I did for Vodo Drive is a lot bigger and a lot more elaborate, but it also has a lot more context that needs to be provided.
All right.
And yeah, so in addition to the system prompt, it also sends in the entire history of all of the messages that have come across so far.
That could be assistant, that could be human assistant chatter, as well as internal chatter about, hey, I need a tool, I found a tool, what's the response from the tool?
Yes,
So it's internal and external
yes,
conversations in the message history. Okay.
yes. In this case, that's how they chose to implement their agent. If you remember with Voodoo Drive, I separate the two. I separate the two a little bit. I don't have all of the internal state constantly represented as part of the chat, but I have a very
Okay.
limited set of that internal conversation that goes on. So good so far.
Yep.
Now this is pretty simple and deliberately so. This is a starter one. It's also a case where it's really meant for the human puts an input in, stuff happens inside the agent, and a response suitable for a human comes out the other end.
Now, generally, I'm assuming that depending on the question that was asked and the tools that are available and the granularity of those tools, you could have multiple calls to the LLM that calls one tool, gets a response back, uses that as input in another tool until it
Yes,
gets the answer, at which point then it gives the response. So when there probably is some sort of, well, there would have to be some sort of a state involved, but it seems like at least on whenever it goes to call model, it's newing up a new instance of the model, open the whatever the open AI chat, yeah, chat open AI. So it's newing up a new instance of that, but it's stateless anyway. You're keeping the state someplace else. So I'm assuming there's some sort of a state management, and it
correct.
might just be in the message history itself, but there could be maybe another mechanism for handling state.
There is. And in fact, that's something that's very inherent to how LangGraph works. So every node is called with the current state that is maintained by LangGraph, and that's the state parameter that is passed in
All
of
right.
type. In this case, it's of message annotation state. And again, since messages are so common, that's a predefined type. So the existing state is passed in, and you're responsible at the end of a node to return updates to the state. You're not supposed to return the new state. You're just returning updates to that state.
Okay. So it's just the delta or whatever, the
Correct.
new stuff, and then it's going to take that object that you return back and add that
Right. What
to
we'll
the list of your history, whatever the list.
well, when we look at Voodoo Drive, and we'll take a little look at how Voodoo Drive does it, you'll see there's actually a set of transformers that you define. So you define how the state changes when you pass back the changes that you want for the state. How do those changes get applied? And it's not always as simple as just add a message onto the end or just add one to the counter. You can have some very elaborate transformers in place.
Okay. So I do want to just bring up one point because it's interesting because this is originally I was thinking that LangGraph was really just about the tools, but it's all about the state and interactivity.
Yes,
So in some ways, I've got a lot of experience working in Jovo, and some of the things that Jovo gives you is the ability to say, oh, here's a request that comes in. I'm going to route the code to some sort of a handler. Well, it's got a, the model that it's using is the old classic style intent, utterance to an intent and slots type of model. But then that helps determine a route, which helps you determine like what the next state is, which helps determine like what the output is and what the possible inputs are for the next turn of the conversation. I know it's quite a bit different. Oh, and there's there's different mechanisms for maintaining state across, from turn to turn throughout the whole assistant, session. So not really saying that there's a one-to-one parallel between those, but in some ways it's really, this would be the core or the heart of your assistant. And that's kind of the similar, type of thing that Jovo is trying to solve for
It's
for more
similar.
classic for more classic NLU type models.
I think that, and there are a lot of similarities. I think the biggest difference here is that LangGraph is more generic. So while what we just looked at is a very simple, small agentic system, you can use LangGraph in a way to say it's going to receive input and do some processing and then send output to a human and wait for a response. And then when that response comes back, do some more work. Or you can use it very similar to Jovo and say, based on the user's input, which node are we going to go to?
Yeah,
You may send it through a classifier node, and then based on the results of that classifier node, have a conditional edge that routes between 5, 6, however many other nodes to do something, whether they be subagents or they just send a reply or whatever. LangGraph is very generic in that way. It's well tuned for LLM work,
yeah.
but it could be used in a lot of different ways, and
Because
it's
I
maintaining the state as you're going along.
Yeah, because I can see assistance being used kind of in two ways. There's the kind of the more free form mode where you're asking questions, or you're kind of, the user is directing where the conversation is going.
Yes.
But let's say that it was something like a restaurant order. So you might like what are the specials on the menu today, or what's good, or what would you recommend, or these, I have a peanut allergy, or whatever it else is, right? Um, so that's kind of more of a free form mode. But I could see where then once you get to the shopping cart mode, it's like I need to do A, then B, then C, then
Right.
D, right? It's like flips into like wizard mode where I have to do certain steps in certain order to finish off the transaction. And so it seems like both can be handled
Right.
in LangGraph.
And I think that's something that people haven't really, and we say this like every other week, that it seems like the LLM world hasn't really caught on to this notion that sometimes your conversations need to be very, very directed conversations,
Yeah,
and sometimes not. And sometimes you need kind of a hybrid of the two, where you're very, very directed, but you need to take side tracks. I think one of the really nice things about LangGraph is that it does handle that model. Now it
yeah.
it, it takes additional work, but there are now ways to define those nodes and those paths. And I think there's also something that I feel like we haven't looked at this carefully recently, and we're overdue again to take a look at Voiceflow and
Yeah.
see, because it feels like to me there's some similarity here, especially since LangGraph has something they call LangGraph Studio, which lets you design the nodes and the edges and design that visually and then
Okay,
run
that's
it
interesting.
visually.
Yeah, and something that we had talked about in a previous episode was this hybrid approach that Voiceflow was taking to models, where
Yes.
you might take your input and run it first through an NLU model and see if it matches any intents. At which point you're like, oh, I know exactly what I need to do. But if it doesn't, then it falls back to more of a LLM approach, where it's like, okay, you figure out this is what I can do, and you figure out if what they said is something I can do.
Right. And again, I think there are a variety of approaches to this. I really do want to see how Voiceflow is handling this sort of thing. And again,
Yeah.
and then we can also compare it to what Google is doing with their agent builder, where it's very similar, but you're describing everything in terms of text instructions. You're kind of giving it a playbook, this broad overview of how things work, and
Yeah.
then letting it figure it out on its own. That's also, I guess, on tap that we need to look at. We've got there's a lot going on.
Yeah.
For all our we don't know what to talk about every week, there's a lot that needs to be talked about.
That is true. I agree with that.
So let's take a look at this for Vodo Drive,
Okay.
and we'll see some differences. So this is the workflow, or the set of nodes for how Vodo Drive is set up. The agentic part of Vodo Drive is set up. And if you remember that the graph that I showed last week when we were talking about Vodo Drive, you saw there were a bunch of blue rectangles which represented the nodes. We have three decision points that were in yellow, three diamonds in yellow. Those are kind of collapsed into two different conditional edges, and I collapsed them because they made more sense that way, and the diagram itself is a little clearer this way. And then we have our start and end nodes again. So we've got nodes that call the tool, call the model. We have a node called report tool, and it's a fairly straightforward one that doesn't do a lot. All it does is it sets up the notification about which tool was just called, and if we're calling it more than once in succession. This is just for display purposes. But this is the node that sets the state so that we know that. A retry tool, which if we are going to retry a tool again, the same tool, then this is what increases the counter so that we don't keep trying the same tool indefinitely without getting any good results.
Okay.
And then one that's kind of the opposite of that says, okay, uh, the tool call succeeded. Let's reset the retry counter. Looking at what the flow how the edges work out, we'll go from the start edge. We initially start by calling the model. Once we've called the model, we're going to possibly route it based on the results. So this is where we say, okay, is it calling a tool, or did it give us an output? If it called
Okay.
a tool, we're going to route towards a tool. If it, so if it actually gave us output, we're going to head to end. So although this looks shockingly similar to the example, no big surprise. The biggest difference, though, is if it's a plain text, it's going to end. But if it's saying to call a tool, then we're going to report which tool it is that we're going to call. So instead of just executing the tool, let's go and report the tool. Report which one we're going to be calling first before we actually make that call.
Okay.
Looking down from report tool, it's going to then actually call the tool, which does the tool execution, gets the values back, whatever. But when we're transitioning away from calling the tool, we're going to check the tool result. And depending on what the tool result is, we will do one of two different things. This looks a little complicated. It's really less complicated than it truly is. But it basically says, if we got a result, or if we got, did we get a result, or did we get an error? Did we throw an exception? What happened here? And while we're at it, let's also check the state and see how many times we've retried this.
Okay.
And if we have an error and we haven't retried it many times yet, then we're going to say, let's go to the retry tool node. But if there is no error, or if there was an error and we've retried it too many times, then reset the retry counter and go back to the node for continuing operation. And basically both retry tool and reset retry counter both go directly back to call model. They just do
Okay.
some internal modification of the state. If we actually look at those, and we can see what that different is, that state difference is in both of them. So for retry tool, it does a couple of checks just to make sure. Remove some messages if they're important to remove. So basically, it says if the message that came back was an error, rewind. We don't want that to be in our history. We want to pretend it never happened. So remove
Okay.
that from the messages. And we're going to send back a special message that says, remove the past two messages and trigger the retry counter. So it increases it. Whereas if we're resetting the counter, we're not going to change the message state at all. And we're just going to reset the retry counter completely.
Okay.
Clear? Little fuzzy? That's
Yep.
a little
Yep.
more, it's a little complicated. These are complicated nodes, which is why I put them as their own node.
Yeah.
Because it breaks up the logic a little bit. But that's it. If we look at, the loop, both of them then go back to call model again to either print out the fact that, there was an error, I don't know, or handle the results from the tool and continue that loop again, or not.
So the LLM is handling the processing of the input, and at the very end, the generation of the output.
Yep.
And it's also being used to evaluate which tools to call in what order,
Yes.
and determines if it's done calling tools.
I think of that as, does it have all the information that it needs to
Okay.
answer to reply to the user?
And if it doesn't, then it determines if it sees if there's a tool that can help it.
It sees if there's a tool that can take it the next step. And I think that's some of the beauty of these systems, is that they can do this multi-step uh, reasoning
Yeah.
and say, I have this ultimate goal, but in order to get there, here's the information I need, and here's the next tool that will get me that information. If we're thinking of weather, for example, and our weather function is just defined as, takes a zip code, and you say, I want the weather, is it raining in Boston? Well, first it needs something that converts Boston to a zip code. So that may be one tool call. And then it will, call the function to get the weather in Boston for a particular date. And maybe it needs to make another tool call for what today's date is, or, something like that.
Yeah.
So it knows that there are steps before it can get the next thing, which may give it the answer.
Okay.
In Vodo Drive, it was get the list of files, open a file, and then take the action that needed to be taken. In some cases, that was writing the data, and then once it's written the data, maybe it needs to read the data again.
Well, I'm actually surprised that it obviously is more nodes and edges than the first sample, but not overly so.
That's one of the things I think I find neatest about this concept, is that is that it is pretty straightforward. I mean, my initial implementation of this did not have doing retries, which meant it didn't have two nodes and a conditional edge, and it didn't have the monitoring part of it. So that was the report tool node wasn't there. It was
Yeah.
almost the exact same number of nodes and edges as in the example case.
Yeah.
But again, I'm just maintaining a fairly straightforward workflow. It's easy to imagine that if you are doing a shopping cart checkout, for example, you do need additional nodes in different paths that are somewhat isolated from each other.
Yeah.
But at the same time, maybe you just implement those as multiple different workflows, each with their own state.
Yeah.
And you have one that up front delegates it to a different workflow. Maybe that's the right approach in breaking it down and managing it. I don't know.
Yeah.
I think it's flexible enough that you have that option, and you can find the thing that works correct for your use case.
Something that concerned us early on, more about with agents and especially with tools, is just the latency and the number of times that the LLM would need to be called. Has that pretty much been solved with more recent versions, or
It hasn't been
is that still a concern?
it hasn't been solved. It's still a concern. I think what's changed a lot though is that we're realizing we can use smaller and faster models to do some of that work, and we can use smaller prompts to do some of that work. One of the challenges that people had very early on was they were trying to pack every single instruction into the prompt.
Yeah.
If you were doing this, then you need to do this, and then if you were doing this, then you need to do, all of that logic can be taken out and included just at the right time. One of the things that I did with the way I set up calling model, there's a lot of interesting stuff in here. This is more complicated than it needs to be. It's doing things like adjusting the temperature based on how many times you've tried it, just so to try to get a different response rather than giving you the same response over and over. One of the things that I try to do as part of it is make it so that the messages that come into it are much more dynamic. I don't include my system prompt as part of this because the system prompt changes depending on which tool is being used, or which tool response just used, or what the rest of the state is. So in some cases, your system prompt contains what files are available. Whereas in other cases, if you've got a file open, it contains the schema of that file. Whereas in other cases, it may contain other things. So I think what we're learning is that we don't need to have one prompt that has everything in it, but that at each round, we can create a prompt that is specifically tuned for that call. And that makes it faster, more efficient, more targeted, more useful at that round.
Do you find that you're wanting responses coming back from the LLM to be in JSON, or is that only if it's a tool response, or how do you handle the structure of the data and parsing out the parts that you need for?
That's a great question. For all of in this case, what I do is the tool stuff comes back as JSON. I'm perfectly happy with normal responses to be in plain text. There are other parts of Vodo Drive that don't do that, that do rely on JSON responses. The agentic part isn't one of it. I could easily see, though, that I would want a JSON response for everything. There are pluses and minuses with that as we're, more and more research is looking into how well does that work? Does that produce better or worse results? And, why should you care? I like having the response that comes back be exactly what I can send back to the user.
Well, and that's partly because tools, a lot of times tools are calling APIs, and APIs a lot of times deal with JSON. So
Right.
I could
And
see.
the tools will be returning JSON back. So that's the easy part. It's when you're sending stuff to a human, what are you going to want to send back? Do you want to send back exactly what came out of the LLM? Or do you want it to have a human response and some other possible responses? So, for example, in Voodoo Drive, when I am parsing an image, I have that returned from the LLM as a JSON structure. But in that structure is a field called summary, and that summary is the immediate human visible response.
Yeah, and I can see depending on like what your client is going to be. So if this is a widget on a web page or versus a mobile app or something, you might want to do some sort of an adaptive card or some a table. There might be some other things that how you want to format or structure the output to the user, and some of that might make more sense if that's JSON, and then you could feed it to something else that would translate that into an image or a table or a card or something.
Exactly. So, for example, you may have something that, you're asking it to generate 3 suggestion chips
Yeah.
based on whatever input. And it would make sense to have that represented as an array of strings or as an array of something.
Okay.
An LLM certainly lets you do that these days.
Well, that's very cool. It's good to get into the depths with a concrete example or two concrete examples in this case. I can start to better understand what LangGraph is bringing to the table and how that works really nicely and connects in with LangChain. So it's just nice to see a working example and better understand how, in essence, you can define your own workflow or pipeline or structure, code flow. Some of it is actually part of the conversation flow, but it's part of the connections from node to node is how does the agent know what to do next? When does it try to call a tool? When does it try to recall a tool? Things like that. So that's pretty
Right.
cool.
And I think that's an important thing to understand is that of all of this, the model ends up being a relatively small part of the agent whole. No, it's a crucial part. It's right in the, it's essential, but there's a lot more that needs to go into it. And LangGraph lets you define those easily. There is
Yeah.
the business logic, there is the routing logic, there is, I mean, it's even beyond just the tool calling logic, which is again kind of built in by default. How do you handle those tools? How do you handle errors? How do you, in either the tool calling or in the model calling? Because the model can generate errors too in Gemini. You can have safety errors.
Yeah. Hmm.
How do you handle all of those things? And all of that is outside of the LLM logic itself. And that's where having a structure to build that in really simplifies some things.
Well, that's pretty neat. I appreciate you taking some time to walk us through this and help us to better understand what LangGraph brings to the table here.
Yeah, it's really exciting. I'm really interested to see exactly what people are doing with it, all of the possible ways it can be used, how to do it with human in the loop, how to do it with multiple workflows. There's all sorts of interesting possibilities here, and I'm really curious to see how it's used and what people do with it.
Yeah.
I can't, if you're using it in a particular way, would love to hear what you're doing. As always, leave comments below, find us on social, and I have a feeling we'll be returning to this and Jovo and Voiceflow another time on Two Voice Devs.
Two voice devs. Take care, Alan.
You too, Mark.